Hi, my name is Mike Watts, and I'm an engineer here at NI. Today, we're going to cover some of the benefits of adopting a standardized measurement framework for semiconductor lab users. And we're also going to demonstrate some of the recent NI product enhancements that will make this easier. Let's get started. Now, across the industry, we see very common challenges that we're all facing. We're seeing increasing device complexity and higher pin counts that are all leading to new measurement requirements. We're also getting squeezed to get to market quicker and at a lower average selling price. This creates a really challenging environment to operate in. Now, post-silicon validation is a crucial phase of the semiconductor design flow, but it also can represent significant cost and schedule risk. As IC designs grow more complex, it's important for engineers to have efficient methods of getting to market quickly. And one approach that we've seen work well is adopting a standardized measurement framework that allows you to help facilitate IP reuse and drive up efficiency of your teams. This is a tactic that we've seen industry leaders use very successfully. And the good news is it's also an area of significant investment for NI. And today we're going to cover some of the product enhancements that will help make this easier. First, let's start with some of the existing software that NI has today. And it's really built around this interactive to automated workflow that I've talked about. So for interactive measurements, we have Instrument Studio, which is our interactive instrument cockpit that you can use to make point and shoot type of measurements for oscilloscopes, arbitrary waveform generators, source measure units, digital multimeters, and other types of instruments. You can go in here and you can configure your layout with whatever instruments you would like to use for that project. You can configure the measurement settings like input ranges and sample rates, and then you can perform point and shoot type of measurements. When you're happy with those measurements, you can export those instrument configurations to file, and that is something that you can use in your automated program. It can be used either directly in a programming language of your choice, like Python or LabVIEW or C#, or you can use it directly in TestStand, which is our test sequencer, our test executive. Then your programmer, your validation engineer, can use those instrument configuration settings as a starting point to develop their custom DUT-specific measurements. And they don't have to reprogram every single measurement configuration setting, allowing them to know that they're using the same settings that the design engineer was using on the bench. Then they develop their DUT-specific measurements on top of that. And when the automated program is ready and it's running, you can actually use Instrument Studio in parallel with your automated program for monitoring and debugging. So you can see the live signals from the instruments, and then if something seems wrong, you can pause your program or place a breakpoint. You can open up Instrument Studio, change some values, and then start your automated program again, and those values will persist into your automated program. So it's a really, really powerful tool. Now, one thing that you might have noticed by now is where we fall short is that it's all at the instrument level. And if you want to develop measurement capability, DUT-specific measurement capability, that still has to be programmed by your validation engineer. And that's an area where NI is investing. And so we are taking some of our core software products like Instrument Studio and TestStand and our driver APIs, and we're extending those capabilities and creating a common standardized measurement framework that exists across all those different software capabilities. What that allows you to do, it allows NI and our partners and our customers to develop DUT-specific measurement solutions that can coexist inside of Instrument Studio and then also follow that same powerful workflow between interactive use and automated use. So NI will be developing DUT-specific measurement solutions on top of this framework. Our partners will be developing DUT-specific measurements on top of this framework. And you can go to an app store-like experience to mix and match and select the add-ons that are most relevant to your job. And that'll get you part of the way there. Maybe 60% or 70% of your measurements will be covered. Then we're going to provide a template for LabVIEW and C# so that you can develop your own add-ons to Instrument Studio. You can use LabVIEW or C#, create a plugin that is specific to the job that you need to do, and then you can mix and match those in Instrument Studio. So you can have maybe one or two plugins from NI, you can have a plugin from a partner, a couple custom plugins, and then mix those to create layouts with instrument channels as well. and then follow that same workflow between Instrument Studio and your automated programs. Except this time, instead of being instrument configuration settings that you're exporting, you can actually export measurement configuration settings and use those directly in your automated program. Now, another really powerful thing that this does is, as of today, Instrument Studio is mainly used for NI instruments. But because you can now host and run LabVIEW and C# code in Instrument Studio, that means that pretty much any instrument that can be programmed and can be automated can be used in Instrument Studio. If it has an interface and an API and you can program it in LabVIEW or C#, then you can add that to your system and see those instruments and use them inside of Instrument Studio along with NI instruments. So that's another really powerful capability as well. So before I cover some of the custom plugin template topics for LabVIEW and C# users, I want to highlight some of the recent products that NI and our partners are developing that are built on this powerful measurement framework and follow that same interactive to automated user workflow. The first is the NI Semiconductor Device Control add-on for Instrument Studio, and this is actually released now. If you think about most mixed signal ICs, one of the most common things you have to do is you have to interface with that device and you have to speak to it. That includes things like powering on the part, perhaps closing relays or toggling elements of your load board or your eval board, and then ultimately speaking some digital protocol to the device under test, like I2C, SPI, or RFFE. And that's something that almost every mixed signal validation engineer typically has to program from scratch. Yeah, NI has great measurement or instrument capabilities, but a lot of times we've left these DUT-specific tasks to the end user to figure out. So rather than having your engineers reproduce this and duplicate this effort, which leads to inefficiencies, we now built that in as a standard add-on for Instrument Studio that follows that same workflow that I talked about before. So you can configure your register map, you can power on your part, you can do interactive register read and writes, and then when you're happy with the way that the device is operating, you can export those device control configuration settings to a file and use that directly in a programming language or in Testan without having to reprogram I2C protocol capabilities. It's really powerful. Now, we also have Soliton, one of our specialty partners, developing our first DUT-specific measurement suite, and that's for a load dropout regulator, or LDO. And this is going to be a canned solution that includes pre-built measurements for common things like line and load regulation, line and load transient, power supply rejection ratio, and other common measurements that are needed for validating an LDO. Now, that's coming this summer, and it will, again, follow that same really powerful workflow. And you can even mix these together so you can have the semiconductor device control panel right next to your LDO panel. So you're controlling the registers and you're doing the LDO measurements in the same experience and the same workflow. Then we're also going to use this same measurement framework to do demonstrations and proof of concepts for our customers as we're engaging with you in opportunities. So as an example, we recently developed an audio ADC measurement suite using this framework, and that's something that we can demonstrate today, and it will be coming in the fall of 2021 as well. So now let's talk about what this means for you and how you would develop a custom plugin using a template from NI. So it all starts with some type of code. It could be existing code or a new program that you're creating for a new project. And so imagine that you have some LabVIEW code or some C# code. That would have a user interface element or a UI, and then you would have the functional code behind the scenes. LabVIEW, that would be your front panel and your block diagram. Then what NI would provide is really two things as part of the template. The first is an XML file that includes the metadata that tells Instrument Studio how to interact with the code. What is the name of the panel as you want it to show up in Instrument Studio? What is the file path for the program? Is it a big panel or a small panel? And some of those other settings that just help Instrument Studio understand how to interface with your code. Then, on the code side, we're going to give you, I'll call it a wrapper. It's a template, but essentially, it's going to include all the Instrument Studio API calls that allow you to handle events from Instrument Studio, from the user, like saving your file, stopping all outputs, or closing Instrument Studio. That gives you a way that you can build into a state machine how the code will handle those user inputs from Instrument Studio. But ultimately, it's a wrapper, and there will be a blank space in the middle for you to input your functional code. And then what that allows you to do is take your UI and run it directly in Instrument Studio as a dedicated panel. And again, you can mix that panel with other functionality, like a native panel for an SMU or the device control add-on that I mentioned earlier. So it's a really, really powerful capability, and that's actually what we're going to demonstrate today. So before I jump to the demo, let me show you what hardware setup I'm using today. The device under test in this scenario is a Cirrus Logic high-precision 24-bit audio data converter. And we're using PXI source measure units to power on the part. We're using a PXI audio analyzer to source a high-precision audio signal to the part. Then we're using NI digital instruments to read the I2S data off of the part. And then back on our host PC, we're analyzing that data, we're performing spectral analysis, and we're returning key measurement parameters to the user, such as total harmonic distortion and noise, signal-to-noise ratio, and spurious-free dynamic range. Okay, so let's jump to the demo. The first thing I'll show you is a LabVIEW example. Now, this is a piece of code that was developed by one of our applications engineers using LabVIEW to test that same ADC part that I mentioned before. Now, here you'll notice that we can control the left and right channel of this particular audio source independently. We can change a variety of different parameters, and we're going to source a sine wave to the part. Then we're going to read back the digital interpretation of the sine wave as seen by the ADC, and we're going to perform some spectral analysis and those key test parameters that I mentioned before. So we'll go ahead and run this program, and we'll go ahead and leave most of these settings the same for now. We'll press run. And here in a moment, we'll see spectral data coming back from the part. I'm going to zoom in a little bit so we can see what's going on at lower frequencies. So I'm using a 1 kilohertz sine wave. That's my fundamental frequency. And so you can see that pure tone here. Then I also see a little bit of the harmonics, and we see some of the noise. This is the reconstructed audio input signal. So this is what's coming back from the ADC in digital and I2S, and we're interpreting that data. Then in the bottom right-hand side, we can see our key test parameters, including our dynamic range and our total harmonic distortion and noise. And this isn't the point of the demonstration, but we're seeing really, really good performance here as well. But the main point here is to just show you an example of a LabVIEW program that's pre-built and running. Now, let's say you take that code and you want to run it in Instrument Studio. What NI is going to provide to you is we're going to provide the template, which is going to come in two forms. Number one is that XML file that I mentioned earlier. So if you open up the XML file, it's pretty basic. There's usually just 5 or 6 lines in here. Again, you're going to give it a name, a unique name for the plugin, and then you can also change the display name that'll be shown in Instrument Studio. We're also going to have the file path for the code and a designator for whether or not you want it to be a large panel or a small panel. So these are things that will have a guide, a developer guide for you, but you'll go in and fill out those details for your application. Then from there, you'll open up the LabVIEW program, and we'll jump to the block diagram. And it's a pretty basic LabVIEW state machine. You'll notice here in these green functions, these are the Instrument Studio Developer Kit API. This allows you to create a session with Instrument Studio and to take events from Instrument Studio, such as saving a project, stopping your outputs, or closing the program. And you have different states within the program so that you can tell the code what to do in that case. For example, turning off an output, powering down the instrument, resetting it, all that good stuff. But really, you're going to really look at this running case right here. And essentially, in this blank space in here, that's where you're going to put your functional code. And so you can copy it directly in, or you can call out to a sub-VI, but this is where you're going to put your code. Now, rather than trying to do this live in front of you today, what I'm going to do is I'm going to take the pre-built example where we use that same LabVIEW code from the audio ADC example, and I'm going to plug it in here and show it running in Instrument Studio. So we'll close LabVIEW for now. We'll go to Instrument Studio. And this is the starting screen for Instrument Studio. Here we're going to go to select a manual layout. And this is where you would normally select the instruments that you want to host in a large or a small panel. But now you'll notice that there's example plugins that you can select and create panels as well. And so some of these could be products from NI or products from our partners, but if you develop any custom plugins based on our template, this is where they would show up as well. And we see the ADC demo here. That was the name we gave it in the XML file. I'm going to go ahead and create a large panel with that ADC demo. And the first thing that you'll notice is that it looks identical to the LabVIEW program, because it is. This is the same LabVIEW program running inside Instrument Studio. And I can run this. I can see the same results back from the instrument. And what we'll do next, we'll zoom in again here. You can see some of the spectral data. What we'll do now is we'll edit this layout to show you how you could easily add instruments into a small panel. So maybe we want to see how much power this part is consuming while we run these measurements. So I'm going to add my SMU channels on the right-hand side, click OK, and I'll run it again. This time around, you'll see the power draw change. We're using pretty basic 5 and 12 volt rails, but you can see the power change on the SMU as we run this LabVIEW code in Instrument Studio. So again, this is available today as a part of Instrument Studio 2021. Now, there's additional things that we're going to do to improve this experience for you, and that's what we'll talk about next. We'll switch back over to the slides. Now, in order to make it easier to follow that same workflow between interactive measurements in Instrument Studio and automation, there's still some steps that we need to finish up. So today, you can run LabVIEW code and C# code in Instrument Studio in an interactive sense. But from there, we need to add the capability of exporting the configuration settings, not just for those instruments, but for the full measurement for the custom plugin. So if you buy a product from NI that's built on this platform, we're going to have that full workflow already covered for you. But if you're developing a custom plugin, in the Q3 timeframe of this year, so probably around fall 2021, we're going to add additional capabilities that allow you to complete the workflow for custom plugins as well. And part of that is Testan. So once you get that exported configuration file, we can also use that same XML file from the LabVIEW plugin example and extend it to predefined Testan step types so that when you have a Testan user, they can simply drag and drop predefined test step types and use that configuration file and run without having to reprogram that same functionality. So essentially, for each step type that you want to define, you'll have a name of the step type, you'll have a file path for where to find that functional code, and then ultimately that will show up in your Testan project. And you could use the configuration file in a programming language directly as well. This Testan workflow shows how you could create a zero code workflow for the end user. So this is one of the enhancements that we're going to add later this year. We're also looking at ways of adding additional measurement abstraction layers or DUT-specific information like pin mapping. Right now, this is still very instrument focused, so you're programming individual instrument channels. But in the future, we're going to add a DUT pin map editor into Instrument Studio so that you can program your custom plugins with respect to the DUT pins rather than the instruments that they're connected to. So really excited stuff to come. If you want to hear about more, please reach out to us and we're happy to tell you more about our roadmap. But that kind of gives you an idea of the direction that we're going. In summary, it is possible to drive efficiency in the semiconductor lab. And it starts with creating a common validation environment for your engineers. That includes standardization across instrumentation and your software measurement framework, which we talked about today. And it all builds towards that goal of reusing measurement IP across projects, teams, and across workflows between interactive users and automated users. These are tactics that we see leading companies using today to get to market quicker, and the value is real. But the conversation doesn't stop here. So if you're interested in learning more after today's event, you can visit ni.com/semiconductor or reach out to your favorite NI contact. And now we'll transition to the Q&A portion of the event. So feel free to ask your questions or type them in the chat pod. Thanks.